Good evening. On behalf of the Cathedral, I'd like to welcome Callum, our esteemed Cathedral architect, to the Cathedral for this presentation. Should fire exits be necessary, go out the west doors. Otherwise, over to you. Thank you.
By way of introduction, this is the first of 4 talks that the IAA have organised as part of our COP campaign. We've taken 4 themes, and the first tonight is retrofit, and Callum McLean, who's one of our most able and active members, is going to talk about that subject. And for those of you who would like to come to some of the other talks, on Saturday there will be a walk talking about the River Ness and its history in the city. Monday the 8th, there's going to be a talk which will be online, and that's talking about smart construction, which is off-site manufacture, which is also part of the climate agenda, reducing waste. And finally, on the Tuesday night is the creative use of spaces, which is Laud and Barr Naismith LDN Architects, talking about some of the projects where they've creatively used existing buildings for new purpose. So all 4 of these strands are vital in the built environment, in the construction industry and in design. And so we're going to, with the grace of the church tonight, we'll be able to put this online, and we're hoping to put certainly our other creative use of space talk online as well. Thank you.
Hello, good evening, and thanks for having me. So one of the first things we are going to have to deal with as a country in terms of addressing climate change is what we're going to do about our existing buildings. And that's what we're going to talk about this evening. So the first question is, what is retrofit? We're wanting to reduce energy demand from all buildings, but we're focusing mostly on the homes this evening, because that's where the bulk of the influence or the push for retrofit is going to come. But a lot of what we're going to talk about tonight is going to be relevant to community buildings and any form of building other than industrial plants, which have got different sets of regulations they have to abide by. So we're looking at reducing energy demand from your home, improvements to building fabric, improvements to technology, improvements to behaviour, and setting defined performance targets. And these are all the key factors that we're going to have to consider when we're looking at retrofit. So it's not just about insulation. And it's also something that's topical at the moment. I think there's a group of people meeting in Glasgow who are quite interested in this sort of thing, and they are creating quite a lot of headlines at the moment. This is our esteemed president, I think, setting a marker down, which is highlighting the issues of climate change and global sea temperatures and sea levels rising. So I'm going to give you a little bit of my background for those who don't know me. I specialise in the conservation and restoration of historic buildings, and I do a lot of work on homes of all sizes. So I do work on small homes, I do work on big homes, I do work on tenements, and I have the honour of, from time to time, helping out with this building here. And we've recently produced a retrofit or a net zero strategy for the cathedral, which, as you can imagine, trying to deal with a building of this type and size is a particular challenge. So we're going to give you 5 thoughts to think about in terms of retrofit. We're going to give you 5 challenges that we're going to have to address through retrofit. And we're going to look at 5 strategies for how we're going to deal with it. So starting first with some 5 thoughts. You'll be able to view it online, the whole presentation. It's all been recorded. So 5 thoughts to think about. So Every property is unique. Buildings are like people. Old versus new technology. It's not just about insulation, and it's a new mindset that we're all going to have to adjust to. So looking first at what we mean by every property is unique. So looking at Scotland's building stock, we have 2.5 million existing homes in Scotland. Of those, only about 10% meet the standards that we're going to have to reach if we're going to deal with our climate change obligations. That's 2.2 million homes that need to be retrofitted over the next 15 years. And those who can do their maths will realise that that's 150,000 homes every year for the next 15 years, if we start today. It's going to take a bit of time to get all the procedures and legislation in place. And every day we delay, that number goes up. So if we delay it another year, it's going to be 170,000 homes every year. And if we delay it another year after that, it's going to be 190,000 homes that need to be dealt with every year. So it is a major challenge that we have to address. 20% of the houses that we have date from pre-1919. So they're traditionally built properties of stone and slate. And they have all of the issues to do with conservation and restoration that need to be addressed. If we drill into that a little bit further, we'll see that the Historic Environment in Scotland have done an audit of our existing building stock, and about 75% of those pre-1919 properties are in a poor condition, so they need a lot of repair work even before we start the retrofit work. So that equates to roughly 400,000 properties, and every one of those is different and presents a different set of challenges. They have different fabric issues. They're all built at slightly different ways, using slightly different materials. They have different levels of occupation. Some are family homes, some are used quite intensively, some are used by people who are out working, who are out all day, every day. Some people stay at home all day. Some are old people, some are young people with lots of children. Lots of different ways that people live in buildings. And as I was saying, they're all in different states of disrepair. Some are in very good condition, some are in a very dilapidated state and are going to require particular attention. So if we look at this particular street here, we've got 3 cottage properties. At first glance, they all look very similar, but straight away, you can see the difference between the 3 houses. So this house here is quite highly insulated. You can see that the snow stayed on the roof there for a long time. This one in the middle has got even a poorer thermal performance, and this one at the end sits in between the 2. So we've got 3 properties with 3 very different challenges to do with insulation and retrofit that has to take place. And the interesting thing is that this is the one with the sash windows. This is the one with the modern UPVC windows, and this one has aluminium-clad windows. So you would think normally that this is the old traditional house that's been kept in a normal standard. You'd almost expect, you'd assume that one would perform quite poorly. This one with the modern UPVC windows, you'd think that's going to be the most energy efficient property, but that's not the case. And it's all to do with the way they're treated. These are the targets that we're looking at. So this is the amount of CO2 that our housing is emitting at the moment. And if we carry on the way we're going, we are going to continue increasing our carbon emissions. This yellow line here is the fact that we are adding more buildings all the time to our housing stock. So our CO2 emissions are going to continue to rise just because the number of homes that we are producing is increasing. If we do some modest improvements just through replacing services and boilers, adding some new technology, we might bring the emissions down to this level here, but you'll see that it is nowhere near the target that we need to get to. The target that we're well, this is out of date now because when this graph was produced, the intention was that we were going to reduce our carbon emissions by 80%. That goal has now shifted and we're now going to reduce them by 100%. So this graph was produced from a lot of statistical analysis and data, and they felt that, well, if we can reduce the emissions from the houses by 60%, we can achieve the next 20% of emission reduction by decarbonising the grid. So anybody who's waiting for the decarbonisation of the grid to provide all the answers are going to be mistaken, because that's only going to provide 20% of the slice of the pie that we need to get rid of. All the rest is going to have to come from retrofit. So this is where our ambitious plans were going to bring us. They're going to bring us down to 60% reduction in carbon emissions through the building fabric. Then the next 20% was going to come through decarbonising the grid. And that was going to bring us to 20% here. Now that was a pretty ambitious target, and things have got a whole lot more ambitious with the ambition to take it right the way down to zero. And again, when all of this analysis was being produced, they were looking at the cost of the retrofit. So this is what this graph is showing. This was the kind of Goldilocks zone, which would provide the most cost-effective way of reducing carbon within an affordable way that most people would be able to manage. Even then, at best, they were talking about £15,000 on average per property for a retrofit. Probably more like 25,000, depending on the complexity of the building that you're working with. But even so, this is where we were going to be working at to get our 60% reduction in the building fabric. These were ambitious figures because they only take into account the retrofit. The first thing that you have to do before you start putting insulation in the building is you may have to stop the water getting in. So there's a lot of repair work that needs to be done before you even get there. If we suddenly move this line over here to 80%, you can see that the costs start to increase quite dramatically as you have to introduce much more complicated measures. So buildings are like people. So what do we mean by that? This is particularly in relation to old buildings, those that are built of stone and slate. So they breathe, so they're not like modern buildings, so vapor can transmit through the fabric. They allow moisture into the outer skin through rain, but then they allow that to evaporate out, and that process of moisture management is very important to them. They move and they flex. They consume lots of fuel. They evacuate their waste, so they produce lots of pollution. They're affected by parasites and bacteria, just like human beings are. They get old, so they wear out, bits need to be replaced, a bit like me. And they have nervous breakdowns. So when you have a change in occupancy, when a building moves from one occupant who lived in the particular property one way, and then it is transferred or sold to a different family, and they use the building very differently, sometimes the building can struggle to adapt because it's settled into a pattern of heating and cooling, and it kind of gets used to that. And then when somebody comes in and they bring in a different strategy for heating and cooling the building, all of the timber starts to move and twist. Suddenly cracks start appearing in the plasterwork because it's operating in a different environment, and it takes time to settle down into that new regime. And we need to bear these things in mind before we start doing the retrofit, because these things need to be thought about very carefully. Otherwise, the retrofit is going to have problems and it's going to struggle to succeed. So we need to look very carefully at the structure of the building and what it is that we're working with. And we need to be a little bit of an archaeologist. So even in this one little wall here, where we're doing some renovation work, we can see 4 different types of stone. Well, we've got stone here, a different type of stone, so there's been some work at some stage here. We've got some brickwork, so there was a later extension there, and then we've got some block work up here. All of these materials are going to behave slightly differently in terms of moisture movement, thermal movement, and how they're going to respond to rain and things. All of that has to be thought about. So there's a lot of investigation work needs to be done before we start. That's what happens sometimes when you start opening up an old building and you discover that somebody's been there before you and left a little bit of a mess here, which eventually caused this entire chimney to be compromised structurally. It had to be taken down and rebuilt. And you've got no idea of what's going on. You just look at it from the outside and you say, okay, there's something going on there. but I don't quite know what it is, and you open it up and you discover a whole can of worms. Some things you can see a little bit more obviously. This is your building telling you that it's distressed. It's not happy with the way things are going in terms of the heat, the moisture, and how that's all managed. And then you get instances of what can only be described as vandalism. Some plumber really took some liberties there when they were putting in a waste for a bathroom there, and the size of the notches that they took out of the joists to fit that in was really quite staggering, and compromised the entire floor because they cut all of the joists all the way through, and that floor was just a bit like a trampoline when you went into the bedroom. So there's a lot of work required to sort that out. And a lot of what we need to think about in retrofit is how we avoid doing this. How do we get all the services and the tech that's going to be needed into our buildings in a sensible way that we're not going to compromise the structure? So treat your building like an old friend. Look after it, and don't bash it about. So a few thoughts about old technology. Old technology, when we're talking about stone, mortar, slates, we're talking about materials that are flexible, materials that are breathable. They're unprocessed materials, so they're pretty much in a raw state. So they're pretty adaptable. They're recyclable because there's no chemicals, there's been no processing, there's no additives or adhesives in it. So it's very easy to take traditional materials and reuse them somewhere else. And we've got a 3,000-year track record of using lime and stone. So we've got a pretty good idea of how it works and what it's going to do. So here's a lovely example of traditional construction. Some of you might recognize it. This is the cathedral where we are this evening. This is across the road. Being built in 1874, and we can see probably those who are interested in CDM and health and safety are probably looking at that stone structure that's gone up there without any support and thinking, oh, I hope there's not a storm tonight. And you can see the stones all here. And latest technology, we've got a horse and cart helping us move the materials around and you can see they've got a lovely little gangway there for people to run up and down and get up to the unprotected edges of the building site. When we're looking at new materials, we need to think about the way they're going to work. They generally tend to be much stiffer, much more rigid materials. They tend to be impervious, so they're designed to keep the water out. Rather than letting the water in and managing it and allowing it to evaporate, they're about stopping the water getting in completely. So it's a different type of way of thinking about the building. They can be composites, so they could be manufactured in a factory and lots of different materials are bonded together to make quite a complex product. Oh, whoops, what have I done? They're highly processed. They're engineered for high efficiency. So that means that there's much more reduced margin for error because they're engineered to be very cost effective, so they use the minimum amount of material that they can and try to get the maximum performance out of it. So it's very easy to compromise them. There's a short track record. Materials that we're using today, I mean, we use them a lot, but we've not used them for very long, 20 or 30 years track record for quite a lot of them. Sometimes that can throw up a bit of a problem. Occasionally, not very often, but when it does, it can be a real problem, as we've discovered in instances like Grenfell or asbestos and things like that. We thought we'd discovered a wonderful new material. Later on, we decided that actually maybe it wasn't as great as we first thought. So we're very much relying on the science. The science is great. There's a lot of people working on it, but it's not infallible. So we do need to be a little bit careful. And here's how we put modern buildings together today. We have lots of panelized construction, comes from a factory and just gets shipped in and craned in and bolted together. Different types of technology, they work differently, and we need to be very careful about how we bring them together. It's not just about insulation. This isn't even about building fabric. This is just climate change. This is what I have to deal with day in, day out. Every time I go and look at a church, one of the first things I look at is the gutters. How big are the gutters? How many downpipes have they got? And you can see that what we're dealing with is much more intense rain showers, which are absolutely overwhelming the drainage from these buildings. The drainage is overflowing, they're soaking the walls, and we're having to deal with a lot of dampness that's coming in and deterioration inside the building. This is a piece of pie which just shows how all our energy is used in the building. You can see here roughly about a quarter to a third is just used by us watching TV, running our computers, doing our cooking, putting the lights on. A small piece of the pie on this one is shown as hot water, but that can change quite a lot. The hot water is something that there's not really a lot we can do about in terms of energy efficiency, because we need a shower, we need to wash the clothes and our pots and pans. So that is hot water that is being used, and insulation and fabric efficiency isn't going to help us there at all. The biggest slice of the pie goes into our heating. Not all of this heat loss is going to go through the walls of the building. A large part of it, almost half of it, is just going to go through ventilation and heat loss through drafts, infiltration, and just heat escaping where we don't want it to be escaping. So, as you can see, the effects of insulation is only going to deal with this little part of the pie here, but we've got to think about all the rest of it as well in terms of how we're going to deal with that. This is a great little book from the Sustainable Traditional Building Alliance. Planning a Responsible Retrofit. This is a resource that's available online, free to download. So very good advice in it, a recommended read for anybody who's looking into this. And it goes into explaining some of the issues that we need to look at. So it's not just about the energy and the environment, it's about healthy humans as well, healthy occupants. If we just focus on heat loss, then we're not thinking about moisture management. Humidity builds up in the house, we get issues with mold growth, we get issues with bacteria, we get issues with rot. It starts affecting people's health with allergies and dust mites. So we need to think about that very carefully as well. Make sure that even though we're trying to tackle heat loss, we also make sure that we manage ventilation inside the building. And the other thing we have to think about is the amenity of the buildings. If we start tearing all our historic buildings down, then we're really going to change the character of our towns, and they're not going to be as nice places to live. If we start plastering air source heat pumps all over the walls of our streets, that's not going to be very nice either, and they're noisy, and it can be a bit of a nuisance. And likewise, if we start plastering them with external wall insulation, that's going to change them as well. So we need to be mindful of this. It's not just about how we live, but it's also about our identity and our culture. And that's very important that we need to think about that. So we'll see that we've got a little bit of a diagram here. This is an retrofitted building, so it's got quite a good balance, quite drafty. It's difficult to heat, so you can see that the energy levels are quite poor, but the health of the occupants is quite good, and it's great in terms of its heritage value. If we only look at doing a single measure here in terms of dealing with energy efficiency, you can see that we're affecting some of these in different ways, and we have an unbalanced building because we've dealt with heat loss maybe, but we've not dealt with moisture management, or we've dealt with other issues, or we've left other ones undealt with. So we start getting unbalanced. Here we're looking at one that's been insulated, but we've not looked at the services. How are they going to operate? Are they going to work well with the insulation that we've put in? Or is our boiler matched to our insulation and to our ventilation regime? And I won't go into these in detail, but hopefully they're fairly self-explanatory. And if you are wanting to look at them in detail, I'd certainly recommend looking at this booklet. So a new mindset, what do I mean by that? Well, this is the new heat strategy in buildings that the government has adopted, the Scottish Government. You can see Mr. Harvey here signed it off a couple of months ago. This is going to bring into legislation a whole new raft of targets that people are going to have to meet. And they're going to have to think about them in terms of how are we going to achieve them. It's going to deal with all sorts of things in terms of how we produce our energy, how we use it, how people's lifestyle, how people transport, how they get to work and back. How easy is it to them to get to the shops? How easy is it for them to get to their work and offices? Everything that uses energy is kind of thought about very carefully in this document. And it also thinks about how we're going to deliver the retrofit agenda. And it's going to be through a range of measures. Some of them are going to be education. Some of them are going to be through incentives, through grants and funding. And some of them are going to be through a hard stick, like taxation or penalties, or other sorts of measures that are going to be pretty unpopular. So we need to start thinking about this very carefully. We need to think about it as architects, because the way we look at projects is going to change quite dramatically. We need to start thinking about how we deliver projects, how we communicate with contractors and builders, and how we communicate with clients. It's going to change for builders a lot, because they are going to have to get into the corners and the really hard to reach parts of buildings that they generally don't like getting into. But they're going to have to do that, and they're going to have to do it right, because part of the whole retrofit process is going to be an evaluation of the retrofit on completion, and you will have to achieve the targets that you set out to achieve through the design process. And if you don't meet them, you're going to be required to go back to the building and find out why you're not meeting them and put that right. So it's not a case of the builder kind of doing the job and taking his pay and walking off, and everybody looking at it and saying, oh yeah, that's a nice job. There's going to be a lot of analysis of it afterwards and checking of things, and if there's anything wrong, they're going to have to come back and do it. So they're going to be involved in trying to avoid the situation where they do have to come back and fix something. It means they're going to have to do a lot of checking continuously through the build process. At the moment, I believe we only need to do a blower test to check air tightness in the building at the end of the project. In the retrofit process, you're going to have to do it at the start of the project. You're going to have to do it at least once through the course of the project, just to make sure that you're achieving the targets you set. And you're going to have to do it at the end of the project, and possibly again afterwards to check the results after that. And for homeowners, it's going to be a big change, because they're going to have to think about very carefully about how they live in the building, how they operate the controls of the building, how they operate the windows, to make sure that it's all going to work effectively. And we'll go into that a little bit more. So ambitious targets create higher risks. If we don't meet these targets, as I say, we're going to have to put things right or look at them. And they also, ambitious targets are going to stress the building. And again, I'll be talking about that in a little bit more. It's going to require determination, because, as I say, we have to get into the hard-to-reach corners. We have to go into all the places that we really tried to avoid going into in the past. But there's no way now. We really have to get in there, and that's going to require a bit of determination. Attention to detail. We're going to have to really kind of work through some of the issues, some of the detailing of how this is going to work and how we're actually going to achieve it. It's going to require long-term thinking, because not all of the measures that we need to introduce are going to be introduced straight away. Part of the process is thinking about a medium-term plan, so that at particular points, when we're moving along the line, we may have an opportunity to do some work. So, for example, if you sell a property, that's a big trigger point. Somebody moves in, they want to do renovations. If a young couple start thinking about having a family, then they start thinking about how they're going to change the house to get that ready for a family coming. Or if somebody's getting on in years and they're going to be, the family's leaving, how's that going to affect? Do they need to reorganize the house and the way they're living? That can be an opportunity to do something. Long-term performance monitoring is going to be an issue in terms of making sure that we are continuously achieving the targets that we set out to. One of the contradictory things about making houses more comfortable is that when we put all these insulation measures in and we put in all these new heating systems, people want to enjoy the new heat. So while before they might have complained about the cold and have been happy to live in a house that was only 19 or 20 degrees, when they've got all this new insulation heating system in, and they can live in the house at 21, 22 degrees, it's a lot more comfortable, they're happy to do that. But that means that the amount of energy they're using has gone up. So all this new retrofit work has gone in, but their base level from which they're working on has gone up. It's contradictory. So human nature is something that we need to think about. So our 5 challenges. Let's have a look at them. Whoops. The current property condition, the disruption that's going to be caused, the technical challenges, bad installation, and the available resources. So, current property condition. There's no point in doing a retrofit property on this, a retrofit project on this property until we've dealt with all of this. We've got gutters that are completely choked. All this water's soaking the walls. We've got some horrible cement pointing here. We've got stone erosion, all sorts of things going on. That is going to be an issue that one of the first things on the list of things that you have to do in your retrofit is make sure that your building is in a good state of repair. There's no point in starting the retrofit process if there's water getting in, because whatever you do is going to be compromised and it's going to end up deteriorating very, very quickly and having to be replaced. Some problems you can see, like that rainwater pipe being blocked. Others you can't. So here we're doing some repairs on a skew. We're opening it up and suddenly we find that all of this arcing is rotten and we have to do more work there. So this is a house where we are getting it ready for doing retrofit work. And we're trying to get it all watertight, but even then, when we do open up the structure, we find more problems that we weren't aware of. We were half expecting that we're going to find something, but here it is. Here's the proof in the pudding. There's always something to find once you start opening up an existing building. The disruption. This is going to be a serious issue for people who have families, particularly those who may not have other accommodation that they can go to, other family properties that they can suddenly move out to. It's going to be a major issue for city centres, because to do a lot of the work is going to be really quite invasive. I mean, we're not talking about doing a little bit of insulation in the loft. We're talking about completely stripping out an awful lot of linings in houses. So while all of this work is going on, where are the family going to live? How are they going to live? If they've got young children, where are they going to go? Are they going to be put into temporary accommodation? Are they going to be taken out of school? How long is all of this work going to take? That's a really important consideration when we're thinking about retrofit and housing. Some of the technical challenges. So we're pushing the envelope. We're really trying to get it to perform way beyond what it has to do at the moment. So that means that we're going to have much higher differences in temperature between inside and out. We're going to have much more extreme levels of moisture management that we've got to deal with in terms of humidity inside and higher rainfall outside. We need to particularly look at tackling junctions and joints where different materials are meeting. These are the points where you are going to get gaps in construction. And when the building moves, these are the bits that are going to open up. These are going to allow air to get past any insulation that we put in. It's going to allow cold air in, warm air out. Infiltration is going to be a serious issue. And a lot of the buildings that we're going to have to deal with in terms of traditional buildings, it's not so much the building fabric, it's the fact that the air is just getting straight round whatever is there at the moment. So if there's gaps around the windows, or if there's gaps at the back of the lath and plaster where air is howling in and around, there's no point in putting in new double glazed windows, because you're not losing the heat through the windows. The heat is just bypassing it. It's going just right around it and through into the back of the plaster. So making sure that we catch all of these little gaps and joints is going to be extremely important in terms of how we're going to achieve the targets. Physical access. I'll show you a couple of slides about some of the challenges that we're going to have to deal with. Fitting in the services, so dealing with ventilation. So do we need to put in ducting for heat recovery ventilation in order to mitigate some of our heat losses? Small cottages don't have a lot of space for running lots of ducts back and forth for dealing with input insulation, input ventilation and extract ventilation. Magic tech and disinformation. So there's an awful lot of material out there on tackling climate change. Some of it is less than honest, shall I say. Like any business that is providing construction information or construction products is going to show their product in the best light possible. Nobody wants to have their product targeted as the one that's causing the problem. So you will see that every product that is out there on the market is going to try and present themselves in the most favourable light possible for tackling climate change. It's not all helpful for consumers who are trying to make informed decisions, and it's something that I think is going to be tackled in the government's heat strategy. It's certainly something that was brought up at the Climate Assembly in terms of having independent, authoritative information on all of the products that are available in the market to try and tackle this. And the impact on or from neighbouring properties. Again, this is a town centre issue. If you retrofit one property and it's attached to another property, there are going to be issues. So you might solve your problems, but you're going to make their situation much worse because the relationship between the two is really quite intimate. So if you have issues, if you're tackling issues of moisture in one building and you address that, but you don't manage the interface with the next building, then all of those problems are going to be heaped on to the problems that are already experienced on the neighbouring property. And there's issues to do with how you get access to do some of this work and what materials you use, particularly if you're using external wall insulation. There's all sorts of issues with fire access and how you manage to put up scaffolding, things like that. So here's a wee diagram that explains or tries to illustrate some of the issues that we have to deal with moisture management. So this is looking at a section through a wall. This is a traditional stone wall. This is the room inside. This is the outside air here. And the temperature drops as we move through a section through the wall. And this is really what our heat loss is all about. And what we're trying to do is trying to reduce this heat loss as much as possible. But we also have to think about the moisture level. So these are our vapor pressures inside the building. So this is our saturated vapor pressure, and this is our actual vapor pressure here. If these two lines cross, then that means that we're getting condensation. And the farther apart we can keep these two lines, then the better, the more robust the detail that we have, because there's less chance of anything going wrong. And if we try and push this point where any condensation is going to occur as far out to the outside of the building as possible, then that's going to protect our fabric of the building. What happens when we do a retrofit is that we get a graph that's going to look like this. And you can see our temperature drops very, very quickly because we're keeping more heat in, and less heat is being transmitted through the wall. But our vapor pressure also drops very, very quickly. So this is our saturated vapor pressure, and this is the actual vapor pressure as we move through the wall. And you can see that they're now very, very close together. So if there's any kind of defect in the way this is built, then this is going to potentially cause a problem with a failure. The other issue here is because we're dealing with a traditional wall, you need a little bit of a difference from the vapor pressure between inside and out in order for the wall to dry out and to manage the moisture. If you get to a situation like this where you've dropped the vapor pressure very quickly and there's no difference in the vapor pressure between the inside and the out, then that wall's not going to dry out properly. It's not going to manage the moisture. Instead of continuously pushing the moisture out to the outside where it can evaporate, it's just going to sit here. And if there's any defect at all in the external wall surface that is allowing excessive water to get in, then that is slowly going to build up over time, and you're going to get a wetter wall. Here's an example. I think this one's taken from Passive House, as an illustration of what happens when you get a gap in your vapor control layer here. So we have a 1 millimeter wide crack in the vapor control layer, and what you find is that over the year, you get 360 grams of water every single day. This is just moisture from the humidity inside the room, making its way through that crack. So 360 grams every day, that's about 7.5 to 10 litres of water in the course of a year. Now, if you can imagine that all going through that one little crack, that's going to create real problems if, as you have, oops, sorry, I don't know why it keeps doing that. If you've got a timber structure in the wall here, so you need to think very carefully about that. And this is where understanding failure mechanisms and the robustness of the details that you're working with is going to be very important. Difficult to get to spaces. Look at this. This is lovely. Years and years of wiring, which electricians never remove. So you get one era of wiring on top of another era of wiring, and pipe works. Plumbers never remove the old pipe work. They just disconnect it and leave it there. So somebody is going to have to crawl through this space and actually physically put in the insulation in there. And they're going to have to get into all these corners, and they're going to have to tape all the joints. And, you know, we're not in the Victorian era anymore. We can't send 10-year-old boys clambering along into these little spaces to try and make it all work. So how are we going to tackle that is going to be a big challenge. Skilled tradesmen, joiners, aren't really going to want to spend their time doing that. But somebody's going to have to do it. And somebody's going to have to check it. And it needs to be done right first time, because if you put the blower test in and you find that there's a gap somewhere, it means that somebody has got to trace their way all the way back through these spaces and try and find out where the gap is so that they can get it all fixed and sorted. So this is what I mean when I talk about a different mindset from the way architects and builders work at the moment. Another difficult to get to space. So this is me crawling around the solum of a house underneath the floor, trying to figure out what's going on. So the client here is complaining that the hallway of their house is absolutely freezing. And the reason why is that they've got a nice ventilated solum under here, and all the cold air is rushing around in here and then just coming up through the stair where there's nothing to stop it. All the gaps between these pieces of plywood here are just allowing the air just to come shooting up. So we solved the problem, or we've identified the problem. The next problem we've got is how are we going to tackle it without actually tearing the entire interior of the house to bits and rebuilding it from scratch. This is an example of a positive input insulation, which was put into a house that I inspected, which had damp problems. Basically what happened is that they have got a very leaky house. So it's a traditional lath and plaster building. It's had a bit of insulation put in, but not very well, as you can see. There's lots of gaps around it. So what this is doing is the warm, moist air that we're generating every day, boiling the kettle, breathing in and out, just living, is finding its way out, as it normally does in a traditional building. It goes out through the walls and up through into the roof space, and usually ventilates its way out. But with this contraption here, what this does is this sucks all the air out of the attic space on the basis that it's pre-warmed, tempered air, because the attic space has been warmed up by the sun hitting the slates. So it takes all of that air, which is assumed to be dry, warm air, and then it blows it in to the house. And the idea is that it will push all of the stale air out through the trickle vents in the windows. So you'll be replacing all the stale damp air, which will be pushed out, with the warm, fresh air that's coming from the attic space. That's the theory. That's what all the sales literature tells you. What actually happens is all the moist air is making its way through the gaps in the lath and plaster up into the attic space, where this thing grabs all that moist, stale air, sucks it back into the house and blows it into the house again, where it just goes into the house, gets damper, more humid, makes its way through the gaps, back up into the attic space, where this thing sucks it out and blows it back in again. So, yeah, the theory is good. in practice, it just doesn't work. So you need to be a little bit careful about some of the sales literature and think very carefully about how you're going to tackle these things. Magic solutions, silver bullets don't exist. It takes just careful thought and careful planning. This is another one. Radiant heat panels. This is all the rage a few years ago, where the idea is that an electric panel heats surfaces rather than the air in the building. So when we have traditional radiators, we heat the air, the building warms up, and we feel the comfort of it. But we're heating a lot of air, so it's using a lot of energy. A radiant panel uses infrared, and it just heats the surfaces that the infrared waves come into contact with. So it's not heating that big volume of air that we have. The only problem is, because if the air stays cold, it can't support all the moisture that people are generating doing their normal daily lives. So we've got a very low temperature of air that's very, very, very humid, because it's trying to absorb all the same amount of moisture that was being generated before. And we end up with all sorts of problems. Have I got a... No, I don't have I think there's a photograph later on. And then we're dealing with bad installation. So this is something that I come across quite a lot. Partly the product of some of the renewable heat obligations that's been placed on our energy suppliers. So some of you, no doubt, have had letters from the council saying, or EDF or E.ON or one of these companies saying, we're doing insulation measures in your area. You'll qualify if you're an old age pensioner or if you're on universal credit, and we'll come and fit all this insulation in your house for free. And so they've come along and they've done it, and they've done the nice easy bits. But this light well, they've decided that they're not going to bother insulating that, because they're only in there to put in this mineral wool. So what's happening is we're getting bits that are left behind, bits that aren't done. So these bits are stopping the moisture getting out here. All that does is the warmth and the moisture will find the weakest point, and it will escape there, and it will escape in a more focused and concentrated manner. Here's another example. This is a church hall that I inspected. Again, they've done all the easy bits. Then they kind of got a little bit sloppy when they got to the edges. So this is the lath and plaster. So the other side of this is what the back of lath and plaster looks like. On the other side of that is the room that's inside. And not only that, the insulation has been installed quite badly, but they also put in radiant heat panels. And this is the result. So we've got lots and lots and lots of condensation. And it's all occurring in the areas where the walls haven't been insulated very well. Oops, what does that say? So, getting reliable information. This is our friend Alistair Allen, quoted in the P&J 3 weeks ago. Is the date on it? Saturday, October, something or other. Alistair Allen claims that we don't need ventilation in the Western Isles. We do. If you've got drafty houses in the Western Isles, it's because they're not airtight. So that's what needs to be addressed. It's the airtightness, it's not the ventilation. And the more airtight you make the building, the more you need to manage the ventilation very carefully. So this is a lot of the kind of nonsense that we're going to have to address in terms of people throwing their arms up, and as soon as they encounter a difficulty or something that sounds strange to them, they'll say, oh, no, we can't do that. That makes no sense at all. And they start making statements like this, which is very ill-advised, because the more insulation you put into a house, the more ventilation you need, and the more it needs to be controlled very carefully. This is the Green Spec website. This provides very good advice for anybody who wants to check whether the credentials of a product that they're wanting to buy stand up to scrutiny, and it tells you what to look at. You know, it's got 10 points to watch for if you want to tackle greenwash, as it's called, and to make sure that your product is going to do what it says. So our 5 strategies for how we're going to sort all of this out. Property maintenance, first on the list. Professional advice, second on the list. In fact, professional advice can come before maintenance because some of the maintenance that needs to be done is going to need good advice. Opportunities that you can take advantage of, attention to detail, and then inspiring outcomes. So property maintenance. Some of it you can do yourself, and it's very important. Cleaning your gutters every year, especially at this time of year when all the leaves have fallen down. Make sure that you're just stopping water getting in or saturating your walls in the first place is the most important thing to do. On a domestic house, it's fairly simple. I mean, it literally is as much as that. Just keeping an eye on it, getting to know your building, spotting when you start to see cracks in the mortar on the skews, or spotting if you're starting to see the paint peeling on your windows, and just addressing it. It can be a little bit more difficult on larger buildings, church halls, community halls, because a lot of the time they've been designed in the Victorian period when the climate was very different. So they were designed with rainwater goods that were adequate at the time, but are completely incapable of dealing with the weather that we have today. But to look at it, you might look at the gutters and say, oh yeah, the gutters look fine. What you won't realise until you do the calculations is that they're half the size that they actually need to be for today's weather. Some work you're going to need to get some professionals in, and you need to get good professionals in who know what they're doing. Professional advice. So I mentioned the eco-heat scheme and the renewable obligations that's placed on energy suppliers for carrying out some improvement measures on houses, like putting in roof and loft insulation and putting in cavity wall insulation, simple things like that. Each Home Counts is a government report that was produced in 2016, so that's 5 years ago now, and even then they realised that there was problems with what they were doing. They were putting in these single measures, then all of a sudden there was mould suddenly appearing on people's bedrooms and kitchens, and they started to realise that this way of delivering retrofit improvement wasn't working, because all of the complex issues to do with moisture management, to do with ventilation, to do with insulation, how people live in the building, weren't being addressed. And that was creating complex problems that the government was having to deal with. And they started to realise, well, why are these things happening? And then why are we providing all of these loans and incentives for people to install measures? Some people were getting them for free if they were in social housing. Private own homeowners could get loans for delivery of the measures, but nobody was taking them up. And the simple reason was they didn't trust. They could see that there was problems with it. They didn't trust the advice they were getting, and so they just didn't want to take it up. So this report came out in 2016, which analysed the whole process and the problems and why things weren't working the way they were expecting them to work. And the direct result of all of that was past 2035, which people are going to hear a lot about over the coming years. Past 2035 was the development of a whole process for how we deal with retrofit, starting at the very beginning in terms of how we assess houses, how we check the condition of them, how we understand how people live in the houses that we're working with, understanding that every house is unique and different and has different sets of challenges, and how do we manage the process to make sure that all of the complex issues to deal with moisture management, to deal with heating, to deal with ventilation, to deal with programmable services that people can understand how to use, how is that all going to be dealt with and managed so that the outcomes are going to be achieved that are important if we're going to meet our obligations in terms of net zero. So this is a process, and I come across this all the time, even when I'm talking to my professional colleagues who may not be aware of the detail of it. So a lot of people refer to past 2035 as if it's a standard. It's not a standard at all. It doesn't set a target for energy efficiency at all. It's a process. It sets out, these are the step-by-step way that we have to go through a project to make sure that everything is dealt with very carefully and thoroughly. This forms the foundation of all of the UK government and Scottish government's heat strategy and how they're going to address net zero and the retrofit challenge that's ahead of them. And besides all of that, we've got some very good sources of information that people should look at and reference if they're wanting to do some study on it. So we've got very, very good guidance from Historic Environment Scotland in terms of how we deal with traditionally built buildings and structures and how we approach energy efficiency and retrofit in a responsible and sensitive way. The Sustainable Traditional Building Alliance, responsible retrofit, again I mentioned that one earlier. Great advice in there, very good, very easy to digest, and I thoroughly recommend that. And then we have Sustainable Renovation by the Pebble Trust, which again is a very, very good document, very, very authoritative, carefully researched, lots of very good advice. And again, all of these are free to download, and I recommend them to anybody. And the key thing is to look before you leap. So we need to think long term, plan carefully, do our research, employ the right people. So bad advice in the long run is going to cost you a lot more than good advice. So when you're considering who to speak to and who to talk to about your retrofit, the cost shouldn't be your first priority. It should be how well do they understand the problem that's got to be tackled and how well are they going to deal with it. The next step, after you've thought about it very carefully, after you've employed the right people, is to carry out thorough research and investigation, really understand how your building is put together, how it's changed over time, what materials are there, what are the problems, what are the defects, and what's the right way to approach upgrading the building fabric. The next step is to design the work very, very carefully. You've done all your research and your investigation, and you think about that very carefully and you address it all as best you can through the design work. And you take your time and you make sure that you do this very, very carefully. Because not only does the design need to be thought about, but you need to think about, well, how are we going to install it? How are we going to make sure that people are going to be able to continue to live in the building while it's going on? Can we decant? Can we do one room at a time? Do we do a floor at a time? Do we move the people out and do the whole building at one go? All that needs to be talked about with the homeowners and the people who are living in the building to see how that's going to be resolved. And you're going to have to design the details and the packages that you're going to put in a way that's going to allow that to happen. So this is all about planning the installation carefully so that you may be able to do the insulation work now, but you might want to leave the heating system till later on, come back and do that. Or you may decide, okay, Boris Johnson's been talking a lot about heat pumps, air source heat pumps this week. He wants us all to put air source heat pumps in. Let's put an air source heat pump in, but we need to do it in such a way that we're still going to be access to the bits that we need to get access to put in the insulation that's going to be required to put in to improve the building fabric later on. So we need to think very carefully about how that's going to go in. If we're going to put it in now, how's that going to affect what needs to go in later on in order to achieve our target? A lot of the targets in the retrofit we're not going to be able to hit in one go, so we need to have a long-term plan. We're going to do this now, then we're going to do that at some point in the future, and then we're going to do this sometime in the future, so that by the time 2040 comes, everything is in place and we've done everything that we were going to say that we were going to do. So we've done all our looking, then we're going to actually carry out the work, so we're going to employ the right people. We're going to carry out the work very carefully, as I've been saying throughout, that all the corners need to be tackled, and somebody needs to go in and make sure they're done very, very thoroughly. And we need to review the outcome to make sure that we've actually achieved what we set out to achieve, because we're not going to hit our targets if we're relaxed about that. You know, if we say that we need to hit our SAP C or EPC level C, then we need to hit it, because every house that doesn't hit it is another increment down from our net zero target. And if we're all relaxed about it, you know, even if we're just missing it by 5% or 10%, all these 5% and 10% add up, And before we know it, we're miles off the target that we actually need to achieve to address the climate change issue. So the key thing is the looking and the thinking about it is the big, big part. This is where we need to spend and invest all of our time. Actually carrying it out is a little bit easier, it's a little bit more efficient, and a little bit more time consuming. So the key thing is we need to focus our energy in this bit, making sure that we get that right, so that when this happens, that's going to be right as well. Professional advice. So RIS architects are thoroughly competent to deal with all of this, and we're fully aware of all of the issues. We've been raising this issues for decades. I was a eco-homes assessor back in the early 2000s. So a lot of us have been talking about this for a long time, and it's only now really that it's starting to come to the fore, and we're well placed to deal with all of this. In addition to being an RIS architect, there's other specializations. So some architects are very very committed to sustainability issues, not just in terms of energy efficiency, but also in terms of ecology and where materials come from, how they're recycled, their whole life cycle from the minute they're extracted from the earth and to the minute that they go back to the earth as decomposition and returned to the soil. You have conservation accredited architects who are specialists in dealing with very historic buildings and ones that are going to present particular challenges in terms of either stone or access or heritage issues. If they've got very important interiors, how you're going to deal with that. And then there's past 2035, which is people are going to start hearing an awful lot more about that in the coming months. So these are all important things to look at when you're seeking advice. And part of the past 2035 is that anybody who's designing retrofit needs to be a professionally qualified person. So it's not just going to be, somebody who does drawings in the garage next door. It's got to be a chartered architect or a chartered surveyor. And in some occasions, there's different levels of risk associated with retrofit, and depending on the level of risk, there will be an appropriate level of skill required, specialist skill from the professionals that are doing it. The opportunities. So timing is everything. You don't have to do everything at once. And the thing to remember is that chance favours the prepared mind. So if you've thought about it early and you've got a plan in place that you've thought about carefully, and you think, well, if I ever get the chance in that part of the house, then this is what I'm going to do. So if you've got that, so rather than doing everything at once, you say, okay, at some point I'm going to get a new kitchen. It's going to happen, maybe not straight away, maybe in 5 years' time. And when I do all of that, I might as well get on and do the rest of the retrofit while I'm at it, because why go through the disruption twice if you only have to go through it once? So have your medium-term plan ready. Be thinking about it. Maintain your access and minimize disruption as far as possible. So try to live in the house if you can and work around it. Be prepared for it. Go beyond energy efficiency. Don't just think about your fabric. Think about how you're going to live, your lifestyle, how you're going to operate in the building. Think about rainfall. Think about all sorts of other issues. Think about the types of materials that you're using. You get different types of insulation. Some of it is hydrocarbon based and it comes from oil. Some of it is natural material, comes from sheep's wool, or it comes from hemp, which is grown, or it comes from wood wool, and it has next to no carbon footprint, and at the end of its life it's recyclable and it causes no damage. Other materials like UPVC, they're very thermally efficient. They're horrible to produce. UPVC is a very dangerous chemical process, and it's almost impossible to dispose of when it's finished. And use it as an opportunity to transform your home. Don't just think about, okay, I've got to put insulation in. If you're going to all that effort in putting the insulation, why not update the design of it? Why not transform it? Why not do some remodeling and introduce a bit of style. So here's a little house that I was working on. So I said, oh yeah, we're doing all this work, let's just knock through the living room and the dining room to make it one space while we're at it, and create a wonderful, wonderful new living space. So yeah, why not? We're in there anyway. We've got the contractors in there. Let's do it. Some things are going to get triggered earlier. So, for example, here we've got the life cycle of various bits and pieces. So boilers, where are boilers? We've got air source heat pumps, condensing boilers here. Lifetime, this is the year 2025 to 2030. By the time we get to 2030, all boilers are supposed to be gone anyway, gas boilers, so they're going. But the lifespan of these things is 12 years. So every 12 years, you're going to have to be thinking about replacing your boiler. Somebody might scoff at this and say, no, my boiler's lasted a lot longer. Statisticians have been looking at this across the country, and this is the average. So over 1 million properties, they can say the average is going to be 12 years. So your boiler might last 20 years, but somebody else's is only going to last 8 before it packs in. Air source heat pumps, again, technology, all of this technology, the more you rely on technology, the more it's going to have to be replaced and the shorter its lifespan is going to be. You get down to insulated doors here, and then fabric, putting in some insulation, nothing's going to go wrong with it. It's going to go in, it's going to operate quite happily, it's never going to have to be replaced. So the only time that it's going to be replaced is when you actually end up doing other work and you're taking down the ceiling and that part of the building ends up getting trashed and you have to redo it again just to restore it. So different things have got different lifespans and different costs associated with them. So timing when you want to do packages of work to coincide with things that you're going to be doing anyway. So if you're going to be replacing your boiler in 5 or 6 years' time, then think about now about, okay, when that happens, I'm going to stick in an air source heat pump. And when I put in my air source heat pump, I need to think about, what do I need to do that? Am I going to need bigger radiators? Am I going to need a hot water tank? What sort of things are going to have to go in to make that happen? Attention to detail. That's going to be getting into all these little corners. How do you deal with the air infiltration and the cracks in the corners of the room that are letting all that air in, and you can't actually get into that? How are you going to make sure that that is breathable and properly ventilated and is going to operate carefully and effectively? It's one thing identifying the problem. It's another thing designing the solution that's going to work. The real problem that keeps me awake at night is, how am I going to be sure that the joiners and the contractors are actually going to install that the way I've designed it, and they're going to do it properly and carefully and be very diligent about it so that there's going to be no problems. And if they don't, and I come back and do my blower test and I find out that I haven't hit my air tightness requirements, how am I going to find out where's the gap, where's the hole, why isn't it working the way it's supposed to be working? Yeah, I think there's going to be a complete change of mindset from the contractors to be able to achieve that. And I don't think they've realized that yet. I think they're going to wake up one morning and they're going to realize. And all of the process of adjustment that's going to be required in the industry to make that going to happen is going to cause a lot of frustration. Tradesmen aren't going to like it when I come on the site and say, no, you can't do it like that. You've got to take that out and do it again the way I've told you to do it. And they'll turn around and say, oh, I've been doing this for 30 years and I've always done it like that and everybody's been very happy with my work. And you have to turn around and say, no, you can't. It's not good enough. It has to come out. So there's going to be frustration, there's going to be tantrums, there's going to be tears until people readjust to a new way of working and a new mindset. There's going to be different skills involved in different posts in contractors' organisations. Until we get to that happy nirvana, there's going to be a lot of frustrated people going around the town in the meantime. So these are some of the things that I think about in terms of all my detail. I've started redrawing all of my details to actually highlight things that the contractors need to pay special attention to make sure that they get right. To identify, well, okay, well, I can show on a drawing how we're going to insulate the coombe here, but in practice, how do you actually physically do it? How do I get the boards in and into the loft space and down that little awkward corner, so that I'm going to get an airtight seal and that there's not going to be no gaps in the insulation. And I need to make sure that at the same time I get getting into all these corners here, particularly this little one in the very corner here, make sure that I get that right. Taping all the joints underneath the skirting boards, getting all that right. Because my field is conservation, I deal with a lot of buildings that are going to have historic linings and important features. So the prospect of going in and ripping out lots of authentic lath and plaster is a real problem for me. On maybe buildings of less historic significance, maybe it's not going to be so much of an issue. But what worries me is how do I deal with that gable? If there's coving on it, if there's plaster cornicing that's quite important to the room, how do I work around that? Without destroying the bits of the historic fabric that are important and need to be kept. So this is what I'm working through at the moment in terms of how do I actually do it? What's the minimum damage that I can do in a building? Again, looking at disruption, how do we get in? How do we make sure that our vapour barriers, if we're putting one in, is going right the way around the corner, is completely sealed and all the joints are taped and sealed, getting around, and that we've got a continuous barrier all the way around. Getting up around all these little ties, making sure that we get into the dormers, that we've got completely sealed an airtight barrier that's going to work the way we want it to. All that takes a lot of care. Architects can't be on site every single minute of every single construction project, looking over the shoulder of the people that are doing it. So a lot of it is going to be relying on tradesmen to do the right thing and to make sure that they're diligent about it. But at the end of the day, we can transform a building, transform a room into something quite nice. I'm not saying that these are any particular pieces of architectural masterpieces. They're not going to appear in the journals of the magazines anytime soon, but they do show just what ordinary people can achieve with a modest budget and a little bit of care and attention to detail. Good. Thank you very much. So the question there is in relation to the building fabric and the different types of building fabric and how you pull that all together. I will have to keep coming back to the same issue that it all needs to be looked at very thoroughly. So it's not just a case of introducing new technology. That new technology brings issues with it itself. So as I was talking about the low temperature that air source heat pumps work. So if I give you just one example, an air source heat pump will only generally bring water up to 55 degrees. Well, I'll come to that. I'll just finish my point about that, and then I'll talk about this building because I've done a zero carbon strategy for the cathedral. So issues to do with air source heat pumps and technology. There's always a lot more in it. As I say, there's no silver bullet. There's no technological solution. All of these issues are interrelated. So, for example, air source heat pumps only bring the water up to 55 degrees. So if you've got a large water tank, if you've got a big community hall and a large water tank, you've got to add more energy into that because you need to bring the water up to 60 degrees to kill Legionnaire's disease. So there's complex issues. So that's just in the water tank. Then there's the issues of you need a little bigger radiators. And then there's issues in terms of balancing that with your ventilation and your building fabric. But if you can recall the slide that I showed you in terms of where all the energy goes, the pie chart, one of the biggest issues you're going to have is air infiltration. And that's one of the things that we are trying to tackle in this building here, in the cathedral itself. Because we can insulate these, well, we can't because it's a Grade A listed building, but if we could insulate these buildings and we could throw as much insulation at it as we could, it's only going to give the smallest dent in our carbon emissions, because we're losing so much air through the floorboards. The cold air is coming in through the floor and it's just going way up there and out through the roof. So all the insulation in the world isn't going to tackle that issue. And if we will need to tackle our carbon emissions, we need to tackle the air infiltration. But it's not just a case of blocking all the gaps, because we do need to ventilate the building. We do need to keep the air healthy, and we need to manage the moisture and the humidity in the building as well. So all of these things interrelate. So there is no, and takes us right way back to the government report for 2016 called Each Home Counts. And that was a direct result of all of the problems that were arising when people just took a one-hit approach to how we're going to improve our buildings. Let's just put insulation. Let's fill the loft with insulation. Let's fill the cavities with insulation. And they took that approach, and then all of these unintended consequences started happening. So the built environment, as I say, it is like a human body. It breathes, it sweats, it consumes fuel. And you need to think about it as a complete ecosystem. And if you do something in one area, it's going to affect another area. And you need to think about what that effect is going to be. And if you need further work then in that area, which then means you need further work in that area, so that you think about the whole complex thing. So it's all about a whole building approach that you need to take. You can't just look at one specific area anymore. So I hope that answers that question.
I enjoyed it. So, okay. So, let me just gather my thoughts first. Yeah. So, basically, I kind of think that the whole retrofit thing, from what you've said, is a bit unachievable for our age, and I think it's definitely gonna push on for another generation. This whole thing that you explained, there's so many red flags for me. I'll probably just list them on. First of all, the execution of this whole thing, as you mentioned, the contractors, that they need to be educated. This is not a one day to the other thing. You can't just go to every person and just tell them to do it this way. It's a mass education. Everybody needs to know about this. It will not happen for a very long time. The other thing that's a red flag for me is the complete stripping out of the historic character of the building. I think that's, as you've said again very correctly, some of these buildings, they're not listed or C-listed, or any other features could be kind of taken away. That's okay, but when you get to B-listed and A-listed buildings, these are just unachievable. And then again, it says airtightness. For me, that goes against the ethos of traditional construction. That's just polar opposites. These buildings, historical buildings, have been put together in a way, and if we disrupt them, then of course we're going to alter the buildings. They will never be the same. The other thing for me was the look before you leap slide. It was mentioned that investigation and design that's, for me, that's a long time, and you said that as well. That's the most time. But for us to investigate, you need to take apart the house, and then putting the design in, that's an additional time. But when you're investigating, the building or part of the building needs to be vacant. So then the design puts in another time. So that's again an issue, because potentially a building could be just vacant for a number of months while we come up with the design. Other thing here is, again, the workmanship and the knowledge of how to get around this. Also, hitting targets, I think that's also a 21st century approach. A lot of people, especially nowadays, we're all about targets. Again, I think that goes against traditions as well. Services are the biggest issue. I've known this for a while, but I think it was one of the first slides you've shown with the piping along the joists, and that's really bad. And you know, when we're gonna start to do all of these things, who is to say that this won't happen regularly? You know, we might be putting more damage to the buildings than we're actually doing good in the long term. Also, if we're doing all this retrofit, say we have a, I don't know, 150, a Georgian building, okay, maybe it's not listed, but it's somewhat intact, and we're going to do all this retrofit, and that means we're going to have to strip everything, and we'll lose the whole evolution of that building and the evolution of use as well, which again contributes to the character. So basically, I think my question really comes down to this: why are we not just accepting that some buildings, these traditional buildings, the way they are, we will do what we can to make them better, like we are doing now and we've been doing for some decades, and we'll just try and emphasize on a carbon-free or a reduced carbon energy into these buildings. So, for example, we could do the heat pumps with underfloor heating, because that's the most efficient way of the heat pumps, and we could then just say having solar panels or wind power or anything else that would be, you know, carbon free. That's basically free, because it's just that. And also the whole kind of assessing, and again with hitting the targets, that's a very kind of passive house type approach, because that's what they've been doing, and that's how they all are. But again, that goes against traditional buildings. And us, I think in Scotland we have a very, very good kind of way, and a very good kind of the technical handbook is really good in some aspects. If we aim for a gold or a platinum level of building, that surpasses passive. So I think passive in this country should be banned, because it's not correct. So sorry, I've rambled on. My question, really sorry, is why don't we just do what we can with careful measures to these buildings, and then just up the kind of carbon-free energy?
Okay.
I want to stop you because I want to hear the answer.
There's a lot to unpack in all of that. Where will I start? I completely understand where you're coming from, Tibor. you'll be surprised that we're on the same wavelength. As I said during my talk, the PAS 2035 isn't a standard. So that's the first thing to remember. Everybody says, oh yes, all our new retrofits are going to achieve PAS 2035. Well, that's a meaningless statement because PAS 2035 doesn't set a standard. And it's a process, and one of the parts of the process is that it does recognize that not every building is going to achieve the targets that are going to be set. And particular care has to be taken around buildings that have got heritage components in them and heritage features. And there is an allowance that says that, you know, if there's an important heritage element to this building, then that is a mitigating circumstances, which means that you can take maybe a less severe approach to the retrofit. So that's the first really important point that we need to make. Now, in terms of what I showed you in the graph earlier, in terms of being able to reduce our carbon emissions through retrofit by 60% through upgrading the fabric, that was the old standard. That was based on the premise that we would bring every existing home and building up to an EPC C rating. So that is a broad view produced by statistics and policymakers and all these people who are talking down in Glasgow at the moment. And they look at all these numbers and say, oh, yes, we'll bring all our existing building stock up to EPC C standard, and that will achieve our goals. Now, the challenge of tackling global warming isn't going to be achieved in the lecture rooms down in Glasgow this week. It's going to be achieved in the little corners of these cottages and getting into the coombs and making that's where these targets are going to be met, by people doing that work diligently and carefully. And people like me are trying to tell these policymakers, do you really understand what it is that you're saying? And how the practicalities of how this is going to work itself out. So all of the details that we're talking about are really, really important. You're correct in saying that traditional buildings need to work in a particular way, and that we need to be sensitive to that and work in the correct way with them. And we need to make sure that we draw the distinction between air tightness and vapor tightness. An impervious vapor control layer is not the same as an air tightness layer. Now, we do need to look at air tightness very, very carefully, because we need to stop drafts getting in and around insulation and making sure that we direct the heat through the insulation so that we're getting the benefit of it. But that doesn't mean to say that we can't still have buildings that breathe, and we can install insulation measures that will breathe and will allow vapor to pass through, but will keep the heat in. And again, that requires different types of technology and different types of software. So the graphs that I showed you earlier that showed the condensation path through the wall, which the technical name for that is the Glaser method. That's kind of old hat now. We're constantly being told that we can't rely on that anymore. We need to move over to dynamic hygrothermal modelling of wall construction. So that's a bit of a mouthful. And there's new software around that can, because the Glaser method is based on a steady state. So it only looks at the temperature inside at one level and the temperature outside at one level. And so it's a static simulation, and it's based on all of that intermediate construction being built perfectly well so that it performs the way it's supposed to be. It doesn't take account of imperfections in construction or things like that. So the modern software methods now build all of that in, and they look at the individual materials, and they look at what happens when the rain hits the wall outside and how that's going to evaporate. And it takes real weather conditions for each area, and then it does all of these calculations over 4 or 5 years, and it models the level of moisture every single layer of the construction all the time. And that's the kind of way we're going. But I mean, that is something that the architects are going to have to learn. The contractors are going to have to learn how to get into all the corners and actually make all of these details work. It's going to be, you're right. And the other thing as well, at the very beginning, I talked about the scale of the challenge. So I'm interested in historic buildings. I can't remember how many I said that was going to be, 20,000 a year, for every year for the next 15 years. The less, or the more modern housing buildings, there's, what was it, 150,000 a year every year for the next 15 years. Where are the people to do that work? The construction industry is overheating at the moment. I can't get contractors. I'm tendering work, and I'm saying to contractors, I want to book this in for June next year. That's how overheated the construction industry is. So how we're suddenly going to find more people to do 150,000 retrofits every year is a little bit of a missing jigsaw piece that the policymakers aren't really kind of grasping yet. But I'm not really here to talk about kind of policy tonight. I'm just here talking about, okay, I'm an architect. This is what I have to do. This is my role in the process. And the other important point was, I was talking about statistics and saying that we need to get an average of EPCC. So for every retrofit that we do that doesn't reach EPCC, that means the other ones have to reach an even higher standard to balance it out. So if we get a few years down the line and we're suddenly realizing that all these traditional buildings are going to be impossible to meet that EPCC standard, then they're going to have to reevaluate what they're going to do with all of the other post-war housing buildings and how are they going to approach those. So yeah, there are numerous challenges in there. And I'm kind of sick trying to raise them with people in higher authority who won't listen to a poor architect like me who's actually trying to make this work. So we take what we're given and we try and make it work as best we can until the people upstairs realise that yes, actually there is a problem there after all. So that doesn't quite answer your question, but it kind of addresses maybe some of the issues. Yeah.
Just a tiny wee bit.
All right. Fesca Mark Callum. Can I ask you a technical question?
Yep.
I bought a house. It was built in 1934 in Inverness, and it was insulated in the roof with 100mm mineral wool. And the house next door and this house had quite a fusty smell in the loft, and recently vents have been put in. That's solved the issue. I was thinking, I've spoken to an architect about this in an informal sense, as somebody I know. Between the joists, which are 120mm deep, I was thinking of putting a 100mm PIR board, which has got a foil in it, so that would create a vapour barrier, my understanding is. And I was worried that that new vapour barrier layer, if you like, it wasn't there previously because it was mineral wool, will cause a damp issue in the joists themselves because that's where the vapour is going to go through. Should I do it?
The question is not so much related to the insulation as related to the ventilation.
Right.
The two go hand in hand. You can't have one without the other. So provided that there's ventilation above the insulation,
Yes.
then in a roof space situation, that's usually solves most issues. If it doesn't, I'm sure your architect is probably aware of what the other complicated issues are. But that's basic premises. Provided you've got ventilation above the insulation, that kind of deals with most situations in the roof. The flip side of that is that making sure that you get the vapour barriers, if you're putting one in, making sure that you get it sealed so that you don't have gaps. So PIR insulation can be a bit of a challenge getting it fitted tightly, snugly between the joists. And then once it's in there, you really need to tape the joints between all the boards or make sure that it's sealed with foam in some way, with expanding foam. preferably with the tape, because the tape will give you a better seal. Well, you need to have ventilation in the internal accommodation as well. So what you're doing is you're changing from a situation where you have uncontrolled ventilation or infiltration, which is coming in all over the place in vast quantities, and you don't know where it's coming in, to a situation where you've got ventilation that you can control, and you know how much ventilation is coming in and where it's coming in, and it's balanced with the amount of heat that you're generating and the amount of moisture that you're generating in the house. So, as I say, all of these things are interrelated and they need to be looked at carefully and thought about. So, without knowing the kind of specifics of your particular project, I can only kind of give you the kind of broad principles that you need to be thinking about. So, what I find is, in most situations, if a roof hasn't been touched and the slates are just sitting there on top of the sarking as it was originally built, the roofs are in great condition and there's a lot of flexibility in terms of the approach that you take. What I find is the worst situation I have most of the times is when I go into a house where it was renovated in the 80s and they stripped the slates and they put a felt membrane over the sarking and then they put the slates back in, and the attic space then is completely airtight and sealed, so the moisture, when it does get into the attic space, can't escape. So you need to, your architect, which needs to be aware, and I'm sure he is, of the various paths for moisture to get in and out of the building to avoid any problems, and also that the interior spaces are properly ventilated to make sure that you don't have any difficulties there. It's doing nothing is not always a solution, because if you've got uncontrolled ventilation, what it's doing is it's making its way through gaps and corners, and that means that you're getting cold spots, what's called cold bridges, and these are areas where you are going to get problems with mold growth and condensation. And the more insulation that you put into the house, the more these little gaps and paths for air to get through become much, much more critical, because when you're stopping the moisture getting out in one area, you're concentrating it and focusing it in areas where it can escape. So the more insulation you start putting into the building, the more these areas become critical and need to be thought about carefully. Okay.
Okay, thanks. I have a follow-up question.
Yeah.
If you had to increase your ventilation to the inner rooms to take account of the fact that you're losing the uncontrolled ventilation, you're going to lose more heat probably through your extract fans.
Yeah.
There will be a point where it's not worth putting that insulation in. And I know you don't know the building, but that's the case, isn't it?
It is a little bit of 2 steps forward, 1 step back, but that's the reality of the situation. So, and it's people are aware of it. They've thought about it very carefully, and there is that issue that you need to take that into account. So, yes, the more insulation you put in, you're not going to get the full benefit. You'll get some benefit, but then, as you say, you increase the ventilation to the spaces inside, and that takes some of that benefit away. So it's constant balancing, juggling different balls and keeping them all in the air and make sure that they work.
My actual question was, I'll put the two together. You talked about the lath and plaster. If you have ventilation happening behind that, presumably that's coming up from the solum, or is it possibly even through the masonry, the solid masonry wall? Is it mostly to do with the solum and the...
Okay, so drafts behind lath and plaster. There are many ways that you can have problems. So, for example, you could have, if you have traditional sash and case windows, and when it was originally built, they had burnt sand mastic around the edges. Over time, that can fall out, and you get gaps around the windows, so air blows in through there.
Yeah, okay.
You can have, often the gaps behind lath and plaster were interconnected with the loft space and the underfloor area. So air that was blowing through the vents underneath the floor were getting up behind the lath and plaster and up through the attic. So you're getting lots of cold air circulating around the plaster. I mean, the ironic thing is, solid plaster on a solid directly onto a solid wall is probably much more energy efficient because you're sealing up all of the gaps and you're not allowing that air infiltration through. So, although you've got less layers of construction there to resist the heat flow, the benefit is because you're not getting that air infiltration through.
One more question.
Yeah.
Obviously, every building's different, but I have been struggling to find out what you typically expect the airtightness of a traditional building to be. And recently, Letty published their retrofit guide, which said 11.5 air changes per hour at 50 pascals. I just wondered if you've tested many and you've got any figure in your mind without testing what you'd expect.
Okay, there's two things there. 11 whatever it is, 11 meters cubed, is it, per meter squared? Or,
So it was the air changes per hour, not the meters cubed per meter squared per hour.
Yeah, it hasn't, air testing of traditional buildings and repair work hasn't really come up much until now, because it's generally been something that's been introduced for new build projects, where you are designing to very high levels of insulation and air tightness to achieve that EPC level. When you're dealing with repairing and renovating a traditional building, often you don't have that requirement to do that. You might only be working in one part of the building and doing some work there. You're not looking at the whole building and dealing with that sort of issue. So that's one part of it. The next part of it is the air tightness test is based on a wind speed, I think it's 20 kilometers an hour. Back many years ago, I studied this at great length because it caused me a great amount of frustration, because I was dealing with properties up in the Grampians and over in the Western Isles, where I was and trying to explain to people that yes, your energy performance was based on a wind speed of 20 kilometers an hour. When the wind is blowing at 100 miles an hour outside in the middle of winter and it's minus 5 degrees, you're gonna have problems. So a lot of these tests and a lot of these standards are based on kind of model situations. And the other part of the SAF test as well is based on this issue of standard occupancy, which assumes that everybody's going to live in the building the same way, and they're going to have the same number of occupants in there, and they're going to use the same amount of hot water, and they're going to have this particular lifestyle. They were designed as a tool for comparing one building with another. So you come up with a design, and in order to kind of compare how well it performs, you kind of need to reduce the amount of variables to something that's manageable, and that you're only focusing on the bits that you control, such as the insulation and the ventilation within specified parameters. So in many ways, a lot of the tools that we use for EPCs and SAP tests are not designed for the purpose of achieving net zero. They were just designed so that we could come up with a design, and we could look at how that performed, and we could tell whether it performed better or worse than another design using different parameters. So that's kind of where we're at with that. So air tightness, coming back to, I would have said, I can't remember the figure you quoted, 11 or something. I would have said that was pretty good for a traditionally built building. I would have thought that was quite low. I think in some instances, generally you want to try it for just people's general health. You want 1.5 air changes per hour in the building. In a lot of traditional buildings, it may be 10, 15 air changes an hour, depending on when it was built and how well it was built and how well it's been maintained. So when you suddenly do a retrofit and all this ventilation drops, it's going to have a dramatic effect, and it needs to be managed carefully. Yeah.
Yeah, I was just going to make a couple of points. One was, I think there's a lack of connection in some cases between what you've got in terms of all the regulations and what actually happens in reality and with the building standards. And I think in Scotland the building standards are doing okay in keeping up with things compared to elsewhere. But the one I had as a matter of interest when you're talking about roof ventilation was we're converting a building, you need roof ventilation. What do you need roof ventilation for? Well, there's no vents, and when we actually looked at the roof, it was 180-year-old, there was no felt in it. So we said, we'll do a near tightness test in the attic and prove that we don't need to do ventilation. The other thing I just wanted to raise, and it's in terms of the whole retrofitting of existing housing, or housing stock particularly, because we do have this legacy of housing that was built in probably the 60s, 70s, where I feel a lot of that stock is almost below the standards that we should be living in these days. We have circulation that you can't move in, you have bathrooms that are too small, kitchens that are too small, and you can't, in my view, it's a waste of investment in a lot of cases to be throwing money into renovating these houses when in fact the actual house that's there in the first instance is it's substandard, which is quite bizarre in modern Scotland. But so there is probably, I'm totally for retaining buildings rather than demolishing and rebuilding them, but I think there probably is a kind of balance that people need to look at in the years ahead, as well as sort of saying we need to retrofit buildings throughout the country.
In my professional capacity, I don't look at many buildings that are built post-war. So I look at them occasionally because they may be part of a church estate, and I'm doing the quinquennial report for the church and the manse, and the manse was built in the 70s. It's a difficult one. I think we need to look very carefully at the locked-in carbon in these buildings. What it's in some respects, it's a philosophical argument. My particular point of view is that we can't save the world by consuming more. So this is why I get quite frustrated by this idea that technology is going to save us. We just keep buying more technology, air source heat pumps, solar panels. Let's just keep throwing it on. That's the future. In my mind, you kind of, the more you consume, the more carbon you're going to generate. So let's try and work with what we've got. And we need to develop the methodology for calculating the carbon that is locked up in buildings, and do the maths to say, okay, how much longer can this life is left in this building reasonably? How much carbon is locked up in it? If we knocked it down and rebuilt it, what's going to be the carbon footprint of that? Too much emphasis in the net zero strategy is just on the operation of the buildings. In my view, we need to extend that. We need to look at the carbon that's in the materials that we bring to site to build with, the carbon that's going to be released when we knock stuff down and we take out material and send that to landfill. And we need to look at the ecological impact of some of the materials that we're going to be putting in, and what effect is that going to... So in my view, it's an issue that's much, much broader than just how much carbon dioxide is my boiler emitting right now, today. So there's lots and lots and lots and lots in that, which I've deliberately tried not to go into. Today I've just tried to focus on, okay, what's the retrofit? Yeah. Yeah, there are issues with the building standards. The building standards are fine for new build. When it comes to traditional buildings, they are still long way behind. Historic Environment Scotland is trying to produce new material to feed into the building standards to say that, no, you don't need to put a vapour control layer into a traditional building. The walls breathe, and it's better if you let them breathe. And in fact, it appears, what was the latest standard? In fact, it appears in Scottish Government guidance on the EPC consultation, where it talks about this very issue. They say sometimes putting a vapour control layer into a traditional building is a bad thing to do, and it has bad outcomes. But right now, if I put in a building warrant application for a traditional building tomorrow into Highland Council Building Control, they will turn around and say, oh, why haven't you got a vapour control layer behind the plasterboard? And I try to point them to all the Historic Environment Scotland guidance and all this guidance and all that, and say, it's a bad thing to do, it's going to create problems. And they'll say, no, the building regulations say this is what you've got to do. I think that's going to change. I think there is so much happening. I mean, right now, in the last 6 months, there's been so many consultations. The whole policy sector is in ferment at the moment, and we've not seen, for most, I kind of get involved in it because of my involvement with the RIS and with BEFS and with other things, and people keep asking me, will you read this consultation and tell me what you think? And it's a wonder I could spend so much time reading consultation documents, I would never get a day's work done. They're just one after another one's coming out, another one's coming out. And I think we're getting to the point where that is all going to suddenly emerge like a dawning. All this new legislation is going to come through, and everybody who hasn't been aware of it till now is going to wonder what on earth has happened. We've woken up and it's a completely new world, and everything that we understood and the way we worked yesterday no longer applies. So yeah, there's all sorts of strange and wonderful things going to happen in the coming months. Okay. Thanks, Karen.
I'd just like to say, on behalf of everyone, to thank Callum for what's been a really great talk. I hope everybody's enjoyed it as much as I did. I think I took, two key messages from it, and you mentioned we should love our buildings, and I think it's the start of a conversation of knowing our buildings better, as architects and as building owners. I think we can no longer be as unaware as we have been probably for the last 20 or 30 years because of the changes that are coming that you're talking about, and the dangers of not knowing our buildings and not looking after them. And as you touched on, one would hope that we go less consumption, more value, and using what we've got and appreciating what we've got. I'd like to have an argument about post-war housing with less, because I think we should keep it all. But equally, what you also were emphasising, the need, you put it as a different mindset, and that mindset has got to go through the construction industry as much as through building owners. And the analogy I give is I went to Japan to see new housing being built, mass housing, and I was utterly stunned. The building sites where you could have eaten your lunch off the ground, and people were, trolleying round all the sections of plumbing, all the sections, and they obviously took away what wasn't needed. And again, when I saw your pictures of, 30-year-old wiring, 60-year-old wiring, you name it, we need to move to that position where, we don't do that in future, that we actually, that workmanship becomes more precise. Because otherwise we're going to get, if we do have all these vapor sealed buildings and airtight buildings, then any retrofit of any description, i.e. I don't mean retrofit, I mean any alterations, risk breaking all the barriers that we've made. So I think it's a fascinating time, and I think I'm a glass half full. I think we just need to get on with it, and it's going to be a challenge. But I think as a profession as well, I think we'll come out of it hopefully being valued for knowledge in a way that perhaps we haven't in the past. That's just a word from the architect here. I really hope so, because I think we hopefully have got as I think Callum and I have talked about in the past, we do see a rounded picture, hopefully, in a way that it's impossible for anyone who's just selling insulation, who's just saying you should replace your windows. So that's my little plug for architects. And thanks very much indeed, Callum. Thank you.